Dear all, a very good day. Today we are going to cover syllabus of our VLSI circuit design, that is TEC 602. We are first going to discuss unit 1, which is the review unit about the MOSFETs. Okay, so in the present video we are going to discuss about the MOSFETs basic. Let's start. Okay. MOSFET stands for metal oxide semiconductor field effect transistor. Okay, if we closely focus on the name of the MOSFET, we will understand that first of all it is a field effect transistor, that is a transistor which works on the application of voltage, that is field, and the controlling parameter in this transistor will be voltage. We all know that transistors are used for two purposes. One is for you working as a switch, and the other is its utilization in the form of amplifiers. So for both the applications, voltage is the controlling parameter in this case. Then comes metal oxide semiconductor. Okay, metal oxide semiconductor means the different components which are inherent to the structure of MOSFET. If we will see, this is a basic structure of MOSFET, which starts from a P substrate, which is the body of the MOSFET. We have here source contact and drain contact, which are connected by a gate. The gate is separated from the main body by a insulating layer of oxide. Okay, so a metallic gate followed by an oxide dielectric material and a semiconductor body. This is what makes the structure of our MOSFET, and hence the name metal followed by metal gate followed by oxide dielectric and a semiconductor body. Okay, now some important things to look in this figure. Source and drain contacts are shown with N positive. These can also be P positive depending upon the type of transistor we want to fabricate. Okay, N positive here implies that it is a highly doped material. Then substrate, that is of P here, P is very moderately doped. Now gate here is made up of polysilicon, it can also be made up of silicon material. Now, the oxide normally used here is silicon dioxide. Now silicon dioxide and silicon materials are used specifically for VLSI application because silicon is first of all a most easily available material. Okay, its properties are very good, though they are not as good as a germanium, but its readily availability makes it very good candidate. Okay, its native oxide grows very easily, that's why this oxide layer will be, maximum case will be of SiO2 material. Okay, so basic fabrication you must have studied in your VLSI course. Okay, let's just quickly review it. That we have a P body and we dope two regions here, N positive regions. Okay, on the P substrate. Now these two regions also form a PN junction, so there will be a semiconducting, there will be N region, P region, and a what is this layer between them? This is the layer filled with in the PN junction depletion layer. Okay, now then over this SiO2 layer is grown. Okay, and over which metal electrode or metal gate is deposited. In a very layman form I have shown you, or I have demonstrated to you the fabrication. Okay, then there are metal contacts provided here to make contacts. Now we need to control the conduction between source and drain electrode. Okay, this is the source electrode, this is the drain electrode. Current will flow between these two terminals, and with the help of gate electrode we need to control this current. Okay, this is so to control the conduction between source and drain electrodes, we we take the help of gate electrode. Now MOSFET is basically divided into two types. One is your depletion MOSFET. In a depletion MOSFET, a channel exists between source and drain contact. Through this channel, conduction of electrons or holes takes place. Okay, whereas the other type of MOSFET is enhancement MOSFET, in which a channel needs to be created with the help of proper gate biasing. Now we are going to look one by one on depletion MOSFET and enhancement MOSFET in brief. So depletion MOSFET, the source, and we are looking here basically in the n-type depletion MOSFET and enhancement MOSFET. The same things can be taken for p-type MOSFET readily. Okay, so let's see depletion MOSFET. The source and drain are both n-type, so electrons will be transmitted, because we know if it is an n positive semiconductor, electrons will be the majority carriers. And MOSFET is basically a unipolar device which favors transfer of only one type of device. So at this time, the channel that exists between the source and drain should be n positive channel. Okay, that is the channel which facilitates movement of electrons and holes. Okay, so channel impedance should be n type. Now when a proper biasing is applied between source and drain, the current flows between the devices. So normally our source is grounded and our drain is connected to a proper biasing voltage which can attract electrons, and they will start the flow of electrons from source to drain terminal or drain to source terminal, and current will flow. Okay, normally electrons will flow from source to drain terminals and current will flow in the opposite direction. Now the question arises, how will we control this current flowing between gate and source electrodes? Okay, so when the gate voltage is 0, the current is maximum. Okay, now we will apply a negative voltage on the gate. Okay, as the negative voltage is applied on the gate, the electrons in the channel are repelled, because gate is also negative charge, electrons are also negatively charged. So this will reduce the number of electrons in the channel. As the number of electrons get reduced in the channel, this will directly reduce the flow of current in the channel, and as a result lower current will flow. So as gate is made more and more negative, lower and lower current flows in the device. Now enhancement MOS working is very different from depletion MOS working. The main reason is that a channel is not present in an enhancement MOSFET, and we need to create a channel. Now for the creation of channel, we need a proper process. Okay, and the process which is followed is of inversion. Okay, so let us look at the few steps which happens. Again we are taking the example of n MOSFET. So if a negative voltage is applied at the gate, Okay, so and whatever the electrons are present between source and drain electrodes, they will be depleted. Okay, and they will be pushed more and more inside the semiconductor. So this condition is known as depletion. Now if a negative voltage is further increased, holes will be attracted to the region between source and drain contact. Okay, and this will result in accumulation. Now accumulation of holes will not help in the flow of electrons between source and drain. So what we need to do is we need to attract electrons. Negative voltage at the gate is not going to help us to attract the electrons. So in this case what we do, we apply a positive voltage at the gate. As positive voltage is applied on the gate, electrons are attracted towards the interface between source and drain. Okay, and there is a particular voltage known as threshold voltage, okay, at which a proper channel between source and drain is formed. Now once a channel is formed between source and drain electrodes, so flow of current can start to take place between source and drain on application of a proper drain voltage. Now if a drain voltage is increased, current flow will also increase. So how can gate control this current flow? If we will make gate more and more positive, it will attract more electrons to the channel, and in this way gate can control the conduction of the channel. Okay, this is all for this video. Thank you.